Okay, so let's talk about virtual switches. Um, to be completely obvious, a virtual switch is a switch that has been virtualized. We know what a switch does. You connect multiple ports to multiple devices on the same network, same physical topology, may not necessarily the same logical topology. Your virtual switch exists, um, runs on inside the hypervisor. It simulates a switch. And you can use these to build a variety of networks and topologies. Everything, practically speaking, that you can do with a physical switch, you can do with a virtual switch. Divide different traffic into different kinds of networks to enable better utilization. You can actually have multiple virtual switches. So instead of having one physical switch or physical switch stack tied into the device, talking to the servers in a rack, you could have multiple virtual switches. And because you can have multiple virtual NICs and multiple virtual switches, really kind of uh, your capabilities your capabilities are limited really only by your technical prowess and your imagination. VM traffic, management traffic, kernel traffic, front end, in any case. And of course we have VLANs. VLANs allowed us to dissociate the physical topology from the logical topology. Each VLAN has a number or a tag, depending on the technology in question, to allow you to logically group different ports on the same virtual switch, virtual ports, virtual switch, virtual LAN. So it's almost a virtual VLAN. And of course, VLANs will do lots of good things. Some of this will group your networks logically, improve performance by confining broadcast traffic. Segmentation has a lot of different benefits. Improve security, save cost by partitioning the network, and it kind of looks like this. So you've got, let's say you've got, what we can actually ignore for the moment the question of whether or not these switches are virtual or physical. Say you've got 3 physical switches, and you've got some 4 groups: sales, engineering, QA, and finance. They don't all have to be physically grouped together to be networked into the same IPv4 subnet or IPv6 subnet. One of the things to note here is each of these VLANs, essentially these 4 VLANs here, each of these should correspond pretty closely to a layer 3 subnet. So layer 2 VLAN, layer 3 subnet. You might have some situations where multiple layer 3 subnets go to a single layer 2 VLAN, but for all intents and purposes, there should be a one-to-one relationship. And what you can do, if you need all these things to talk to each other, you trunk them together. If you haven't talked about trunking all that much in your networking classes so far, a trunk line essentially allows a switch to carry multiple traffic from multiple VLANs down that trunk at the same time. These ports that are framed out in red here, these would be your access layer network. Access ports can only be in one VLAN, at most 2, if that port also corresponds to a voice over IP phone, say with a physical computer daisy-chained off of it. That's what we would call a dual-use port. And that port would be configured to know how to tag the voice VLAN and how to tag the data VLAN. But most of the time, you should have one and only one VLAN for each of those access ports. Whereas a trunk port can carry any kind of tagged traffic as long as it's on the list. Depending on the kind of hardware that you're using or the kind of hardware that you're simulating, the exact details will differ. So we've got these 2 trunk ports, we've got these 4 VLANs, and everybody can talk to each other despite not being, and have the same kinds of security, the same kinds of access or lack thereof, same kinds of DHCP addresses or static configuration or whatnot, regardless of physical topology. That's actually a theme that you'll see over and over and over again. dissociating the physical from the logical, and even the logical topology from the control plane. We're controlling as much of this stuff as possible. In the old days, your physical topology and your logical topology were the same. Then with switches and routers, we could break that. If it turned out that your logical topology needed to be one way and your physical topology another. And now, with what we'll discuss next, software-defined networking, you don't even have to manage the individual devices. You can change your logical topology on the fly. And now with truly virtualized networking, the software-defined data center, you can change the physical topology and the logical topology all on the fly. We'll be right back with that.